Okay, I think we got her. Okay, so anyways, you guys, I know when you guys left, we run slide 13. But what I don't know is where we finished. Did we actually finish this, or did I just yell at you, the answer is, and then you left? Is that what I did?
We finished it.
We did finish it? So what was the answer?
Does not exist.
Does not exist. Okay, all right. So this one is does not exist. Gotcha. But you know what? To be honest, I kind of want to do it again. Just really quick. I'll do it, and then I'll go right to the next slides. Kenna?
Is it always going to be does not exist if it's x minus 1?
On the bottom? No, not always. There's times when it does not exist, and then there's times when it does exist. You have to be patient with me because when it does exist, it's going to happen tomorrow. Okay. Anyways, I just want to remind you what this says. When I say the limit, I'm saying what's the limit of this function right there, x plus 2 over x minus 1, and then what does this little piece down here say? What does this say right there? Okay, the limit of x plus 2 divided by x minus 1, then what does this say to you? As x approaches 1. That's what it says. So when you do this, look, here's 1. When you approach 1 from the left and you approach 1 from the right, what is the answer? That's really all the limit is. The answer, the y value. Well, we said yesterday, make a table. And you do know at 1, that's the limit. But as you approach 1 from the right, you would go most likely 1.001, 1.01, and 1.1. On the other side, you do what? .999. See, these two numbers are exactly the same distance away from 1. What's the distance? 0.001, but that's 1/1000th away. Okay, this would be 0.99, same distance as this one, and this one would be 0.9, same distance as this one. Okay, what did we say the answers were? Oh, by the way, I don't even think, did we even do these two? I don't think we did these. What did we say the answer was if you put 0.99 in?
Negative 299.
Okay, thank you. And then what was this one?
Negative 2,999.
Okay. And then we did not put 1 in. Because if you put 1 in, guys, what do you get?
Error.
Error. It doesn't even give you a limit, so you can't get it anyways. So then put this one in.
3001.
3001. This one? 301, something like that, right? So what I'm trying to tell you is this. As you come in from the right side of 1, look at the numbers. They get what?
Bigger.
Bigger, bigger, bigger. Guess what? You're going to basically turn the corner and get bigger, bigger, bigger. You're at 3,000 when you put in 1.001. So this thing's shooting way up, and then what happens is it goes this way. If you kept going a little further away from 1, you'd get that. On the other side of 1, at 0.999, you're at negative 3,000. At 0.99, you're at 300. It's going down. And then probably over here it goes like this. So what happens as you approach 1? Look, you approach 1. Does the graph go towards 1 number or just totally opposite directions? Yeah, you're going positive infinity. You're going negative infinity. You're not even getting closer and closer to any number. You're actually going opposite directions. There's no limit in this one. Does not exist. You okay with that? Why it doesn't exist? Give me another, for instance, when it doesn't exist.
Would it be a parabola?
Okay, it can be, but you got to explain more.
When you have like two lines and they don't even like meet at the same place.
Okay, so you're saying
It goes like that,
something like that, forever this way.
and then they go in like some other direction, like towards that one.
Like that.
Yeah.
And then maybe an open there. Because if this number happened to be 5, 5 can only get one answer. It actually belongs with this function, not this function. But yes, this is another one where you say what? Does not exist. Because if you came in from 5 on the right, you would get this. So you're approaching that number. If you came at 5 on the left, you'd get this. You're approaching that number. And that number might be 3, and that number might be 10. So if you're approaching two different numbers, because you need to pay attention a little
I
bit.
have been paying attention.
Okay? Then there's no function. Or sorry, no limit. My fault. No limit. Does not exist. Okay? Does that make sense? Asymptote, or you are approaching two different numbers. Does not exist. Okay? Good? That was yesterday. Brittany, I hope that sort of helped you a little bit, because now I'm going to go on to the next 3 slides. Okay, so go to day 2, which is this one, right? Okay, here it is. If f of x equals 2, what's the limit of f of x as x approaches 5? First of all, can you write that limit for me? Write it the way you normally see it in the book. So start by doing this. Okay, write the limit of what as x approaches what? Just write it out. So what'd you write? The limit of 2, because the function is 2, and then you wrote as x approaches what? 5. Okay, so here's the question that they're trying to get after. And by the way, before I talk any more about this problem, I forgot to tell you, this slide is all about the properties of limits. And the properties of limits are found on page, here it is, right here. Page 8. There it is, 855. So if you want your properties, they're right there on that page. There's about 6 properties. I'm only going over 2. So the rest of the properties you can read about. And really, the only reason you want to know the properties is so that it can do what to you? What do properties do for us?
Help you go faster.
Help you go faster, exactly. It's all about speed. Do you want to go faster? Learn the properties. If you don't want to go faster, do what I keep telling you to do. Make a table. Look at the graph. Okay? All right, here we go. This property. I'll show you what the property is after we figure this out. What's the limit of your function 2 as x approaches 5? How do you want to tackle this? Do you want to graphically do it, or do you want to make a table?
Graph it.
Graph it? Okay. Maddie, do you know what this looks like, this function 2?
Yeah, it's just a horizontal line.
Okay. Hang on, Maddie. Why is this? No. 1 second. Okay, Maddie, you say it's a horizontal line. Okay. Okay, where does the horizontal line go through the x-axis? Sorry, the y-axis, my fault?
At 2.
At 2. So really, guys, remember y, or f of x is really just y equals 2. So here I go to y equals 2. I draw my line. There it is. There it is. And now let's look at the limit. What's the limit of 2 as x approaches 5? Here's 5 from the right, from the left to 5. What kind of answers do I get?
2.
All of these. All of these. So I'm approaching the limit. There's the limit right there. Well, what is the answer? It is 2. Just like you said, 2. So what's this property telling you? Anybody?
If the limit's just a regular number, the actual limit will be equal to that?
Exactly. If the function is just a number, a constant, if the function's a constant number, 2, 4, 6, 8, then I don't care what I tell you to run into. I can tell you to run into 5 or 7 or 12. The answer will always be the constant number 2. So here's what the property says. If you go to your book, the limit of b as x approaches c will always be what? And by the way, b is a constant number, like 2. So what's the answer? What? It's what? It's b. It's b. You'll always get that answer, b. I can say as x approaches 5, but it's going to be b, whatever b is. Doesn't matter. So that's the first property they went after. Look at this one. Again, I think it's important that you write these out as I taught you. Okay, so if g of x is equal to x, what's the limit of g of x as x approaches 5? So again, I would probably start by writing this one out. What's the limit of what? X. X is the function. As x approaches what? 5. There you go. That's how you should write that. How do you want me to do it? Should I make a table or should I just graph it?
I don't think we have to do either or.
You don't think we have to do either or?
I don't know.
What do you want to do then?
I don't know.
You kind of have it, Gary, and I'm just curious if you knew what. I wanted to hear what you were thinking.
I don't know. I was thinking that the limit would be x because it's just like 2,
Okay?
but that's not really.
Okay.
Yes.
I think we need to graph it. Because you're thinking it's x, okay. Here's what I would do. I'd graph your function x. By the way, x is 1x plus 0, so it's just a what? It's a line. That's all it is. So let's graph it. Ready? Where's the y-intercept? 0. And what's the slope?
1.
1 over 1. So it's up 1 over 1. Up 1 over 1. Up 1 over 1. There it is. There it goes. And it basically, they want you to go to 5. From the left, from the right, head towards 5. What's the limit going to be? Well, look. As you come in from the left, you keep getting these answers, don't you? There you go. You're getting all these answers until you get just about to 5. From the right, you'll get this answer, this answer, this answer. You're coming in this way. Right there. There's the limit. You're reaching this point. It's that number. What is it?
5.
5. The answer's 5. Anybody want to tell me what this property says? The limit, here's what it says. The limit of x as x approaches c will always be c. There. That's another property when it comes to limits. Hey guys, there's 2 or 3 more properties, maybe 4 more properties you should read about. If, like Olivia said, you want to go faster, read about your properties. I don't care. If you don't want to read about them, then you'll just have to do it the long way. Make a table. Oh, it's 5. Or look at the graph. It's 5. You can do it any way you want. Okay? Does anybody kind of look at this and go, wait a minute. There's a faster way to get that 5. Just plug it in. If you just plug 5 into x, what do you get? 5. Can you do that? Is that okay? Look at the next slide. Let's see if it's okay. Ready? And the next slide says, oops, I went too far now. The next slide says, most functions have limits that are very what? Easy to find. Why is it easy to find the limit of a function, especially like that one? 2x minus 5. Okay, add this in, please. Add this in. as x approaches 3. Okay, my only question to you is this. Why is it easy to find the limit of that problem, 2x minus 5, when it looks like that?
You put it in text. Like you put in 3.
So you're telling me just directly substitute the 3 in? So you're telling me to do this? So that'd be 2 times 3, take away 5, 6, take away 5. The limit is 1. Is she right? Is the limit 1 at 3? Here's 3. 1, 2, 3. As I come in from the right, I get these. So here I come, this way. As I come in from the left, I get these. Is that 1? Sure it is. But Olivia, you just told me how to do it. Why is it easy to do this? Why can I do what Olivia just said? Because it's a line? Tell me more about that.
Because all points on the line exist.
Because all the points on the line do exist.
It's
And
not a fraction.
it's not a what?
Fraction.
This is not a fraction?
It doesn't have like a numerator.
Yes. You
They're
guys
all
are...
connected.
You what?
They're all connected, like for sure.
They're, okay, we're getting so close now. Basically, all the points are connected to form a line. It's a continuous graph. I was waiting for somebody to say this. It's a continuous graph. It does not run into what? What's this? It does not run into an asymptote. It doesn't do this. Look, look, see this? It's not a broken graph. This is a broken graph. Line, line, they don't meet. If it's continuous, it's easy. So write this down. Because the graph is continuous. And because the graph is continuous, this is easy. All you got to do, substitute the number in, and you're done. Okay. But what else is continuous? A line is continuous. What else is continuous?
Parabolas.
Parabolas. What's this one down here? X squared is quadratic. It's a parabola. This is continuous. This should be easy for you guys to find the limit. What else is continuous? Linear, quadratic, linear, line, quadratic, parabola. Come on. Cubic is one of these. Remember cubic? Looks like this. It's like kind of a funny little curve like this. Or sometimes it's this. 1 turn, 2 turns down. That would be easy. Linear, quadratic, cubic, quartic. God, that's good. Period 4 was like looking at it like, what? What's after quartic? Quintic. Yes. Good job, guys. All right. Guys, find the limit of that one if you can. Anybody got it? What's the limit of this one? 0. How'd you know it was 0?
Plug in the 1.
I think you plugged in 1. 1 squared minus 3 times 1 plus 2. 1 minus 3 plus 2. 0. The limit is 0. Hey, I want to just tell you, if I would have graphed this one, I'll show you what the graph looks like. At 1, at 2, here's what happens. It comes like this, this, this. Would you guys agree at 1, at the number 1, coming from the left, coming from the right, would you agree we're approaching this point, and this point is what? 0. So, I mean, you can see it by the graph. You really can. Okay, but I didn't have to graph it because it's a continuous graph, and if it's continuous, just throw the 1 in, and you get your answer. Okay. This is the last slide. I know you guys say there's 2 more slides, but there isn't, because the next slide is the same thing. Okay. All this slide is for is one thing. How to find a limit. Sorry, how to find if a limit does exist algebraically and what the limit is. Okay? So here's what you do throughout the entire assignment. It says substitute the C value into the function. This is called direct substitution, by the way. And if you do that, here's what could happen. If you get a real number, you have found the limit. Okay, write this down. What's the limit of 3x as x approaches 2? What's the limit of 3x as x approaches 2?
6.
Direct substitution. Plug it in. You're going to get 6. Guess what you just found? You found the limit. The limit is 6. So guys, if you ever get an answer, when you put a number in, you found the limit. Do you know why that's the limit? Because this is a continuous graph. There are no breakups. It's just nice, and you're going to find it. Every point is connected to the next point. If you get an undefined result, like this, n over 0. And by the way, n over 0, I'm just saying something like that. If you ever get 3 over 0, 4 over 0, the limit, what? Does not exist. Why not? This means there's a what? You just ran yourself right into what?
Asymptote.
Asymptote. They're going like this. They're coming at each other. Looks like they're going to touch, and then all of a sudden they go like this. Okay? So, that would be a problem like this. The limit of, let's go x minus 6, x squared minus 6x. As x approaches 6. Okay, put the 6's in. What do you get? Substitute it in. On the bottom, you get 0. On the top, what do you get?
0.
Oh, you get 0 over 0. My fault. Guys, I jumped ahead of myself. This was the next problem. Sorry, if you wrote that down, can you change the top to this? Can you change the top to just x? Put the 6 here, put the 6 there. Now you get 6 over 0. What does 6 over 0 mean? Yeah, you ran yourself into an asymptote, but it also means the limit does not exist. If you ever get 5 over 0, 7 over 0, there's no limit. Okay? Now, this last one says if you get the intermediate form, 0 over 0, then more work is required. Because why? The limit does exist. Now, but there's a hole. It says, but there's a hole at C. And because there's a hole at C, it doesn't look like the limit is really there. It is. It's there. Okay? Now, the more work I'm talking about. How do we get that limit? Well, guess what? You don't know how to get it. I'm just going to write these words to you. Coming soon. I will teach you how to find that limit tomorrow. So tomorrow's lesson will say, oh, what if there's a hole? How do we find the limit? I'll show you tomorrow. All right? So I guess on this last one, can you write this down? What's the limit? Now let's throw in x squared minus 6x over x minus 6 as x approaches 6. How about that one? Throw them in. What do you get? 0 on the bottom. 0 on the top. If you ever get 0 over 0, the limit is there. It's there, guys. You just right now, you don't really know how to find it. There is a way to find it. It's algebraically, it's factoring. I'll show you tomorrow. Okay. But for the most part today, you will actually put a number in and get out an answer. That answer is the limit.
So if we get that today, do we get that today?
You might, this one?
Yeah.
You won't, I don't know, you won't get this today.
Okay.
But I'm trying to tell you, when you guys, if I were you and I took the test today, like I could give you the test right now, you could probably do a lot of it already, because if you plug a number in and you get that number, you found the limit. If you got this, that's nice. Why is that nice? Because it doesn't exist. All you got to do is put what? D&E. There's only one thing you don't know how to do yet. It's that one. I'll teach you that tomorrow. still, the first page of the test is practically this stuff right here. Just, I give you a function, I ask you the limit when x approaches 6, you plug 6 in, you see what happens. If you ever get this, there's a procedure to do. I'll teach you tomorrow, you'll be good. It's not hard either, so I'm done. It's up to you now. Do day 1 if you're that far behind, or get going on day 2. Day 2, period 4 people, the people that got day 1 done, they were done with day 2 in 20 minutes. Because it's just substituting numbers in. That's all it is. And you have 20 minutes. You want to start? You want to start? Okay, get that. Go.
This one. I get my math book.
I have math books up there. You're coming in. No questions?
No, I think they're good.
I think you're good.
Where are you
Oh, right up there. Second shelf from the top, on the left.
Can I go use that? That kind of goes into what we were doing in yesterday last year.
You want to try it? Okay, number 3. I'll do 9. Hey guys, I'm gonna do 9, number 9 in about 2 to 3 minutes. Okay? And I want to say this right now, number 6. I think on the calendar I said I'll do it with you.
Yeah.
Just get rid of it. Period 4 said, can it be bonus? Because I already did it. Sure. It's example 1 in 12.1. I just don't want to take the time to do it because really it's just talking about what is a limit. And if I eat up another 10 minutes of your class, you guys, you want time to work. So let's just say, don't do 6, unless you already did 6. Who already did it?
I tried.
Just one person?
I skipped
Tried?
as you said you were going to do it in class.
Yeah.
But you can go back and do it if you want.
Yeah.
If you. Okay. Okay.
I'm the
So
last problem, or second to last problem.
day 1, day 2. Day 2. So you're fine?
Yeah.
You okay?
Yeah.
Okay. You good?
No, I'm good.
You're good. You okay?
Other than the fact that sometimes I just grasp on my calculator and it just, it's not this one. There was not, but just when I was doing it, it was.
Do you remember which one it is?
21, I think.
Okay. Do they watch you?
Yeah.
Users don't do this. Using that. Okay, yeah. All right,
Okay,
I'm gonna watch you. Go ahead.
Okay, I looked in the back because that's how I got them, but.
Okay.
This is number 21. But it was sine squared, wasn't it? That's why something happened there. So now, sine squared is, here's what sine squared is. It's just sine of your angle. Whatever the answer is, square it. Don't square the angle, square the answer.
It's true that genetics is because they can approach two different. Is that just what you wrote? Okay.
See, what you're doing is you're squaring your angle though. That little square sign belongs on the outside. Actually, it should be like this. Sine of x. Whatever all that answer is, square it. That's the problem. I know it is. Hey guys, 21. 21 looks like this. Sine of x. Does it have that, Maddie?
Yeah.
Yeah, over what?
Over x.
Over x. When you punch this into your calculator, punch it like this. You want to tell your calculator sine of x. Then you want to tell your calculator take that answer, square it, and then divide it by just x. That's all you'd have to do. But people get messed up on this. They don't understand what sine of x squared really means. It's just sine of x, the answer, squared. So type it in like this or else I think you're in trouble. It doesn't work? Okay, let's see. My phone, that's my phone. Better get that.